Aloha Touch Designers. All right, we're going to continue on with this slot machine project. We have a bunch to do. We probably won't finish it all tonight. I'm going to try and keep this online lesson a little bit short. But you should have, in the last week for your homework, added this button and added some graphics to the slot machine. I'll go over that, how to do that really quick, but let's look what we have to do. So currently we got if you have the button here placed, then you should be able to click it and the machine will activate, and it doesn't currently stop in order. We want this wheel to stop first, the second wheel to stop second, and the far right wheel to stop last. Currently, sometimes it does that order, but other times it doesn't, as you can see. Right, so this is totally backwards. So we need to fix that. We also need to add a mechanism to make these numbers stop when they're at a whole number instead of being like halfway in between numbers like they are now. Right? So let's see how we can do that. First of all, I'll go ahead and review, if you didn't do the homework, how to do this button. It's pretty simple. You can add a button and then dive inside the button and get rid of the background and the color information. You don't need them. Then dive out of the button and now you have an invisible button. But in order to put it where you want it, you're going to want to turn on the borders for it. So you go to Look, and on all these different border drop downs, you set them to border A. Then you have a white outlined button down here, right? So then I open this view like this. I can, under the parameters, change the width and size, something like 100 by 250, and then slide the X and Y over until you get it where you want it, right? The other thing is to add that graphic. I'm going to go ahead and get rid of this second button. We don't need it. And that's simply just adding another geometry component. And inside the geometry component, we have a rectangle SOP and attached to a material SOP. And that has the render and display flags set. Then we also have the graphic just dropped in there. It's a movie file in top, and then that is mapped to the color map of a Fong material, and then the material SOP down here points to the Fong material. Okay, so then you can create a graphic of the size that would fit inside the machine and move it into place. I actually did. I'm seeing now I did kind of a sloppy job. I'll fix this, but probably not in this video. Let's see. Okay, so so we need to, the first thing we should do probably is add that whole number stop, and that's going to be inside of these spinner components. So dive inside the first spinner component. First thing here, I have the LFO here, and that's only going from 0 to 1, and then it is sent to a null for some reason, and then sent to a math that ranges it from 0 to 10. That is just a little unnecessary, so I wanted to fix that first thing. So here under your LFO, change the, let's see, here it is, amplitude from 1 to 10. Okay, then it will create automatically a number that goes 0 to 10, and you don't need this extra stuff. So I'm going to get rid of the null. I'm going to get rid of the math. Now I have a LFO that goes from 0 to 10. Let's go ahead and do that in the other two spinners so things stay consistent, and just have to delete them and the connection stays connected, which is a great thing about Touch Designer. So there's spinner 2, spinner 3. Get rid of the null, get rid of the math. Oh yeah, I think I forgot to set the amplitude in spinner 2. I'll have to go back. Change the amplitude to 10. Spinner 2, let's go back to spinner 2 for a second. Here, the amplitude, this instead of being 1, that should be 10. There we go. Okay, so now let's go back to spinner 1. And remember, if you're ever lost and you don't know where I am, you can always look up here. This tells you where I currently am, okay? All right, so what we need to do is add another chop exec, this time attached to this LFO. And we're going to use the changing values on the LFO to execute a small piece of code that will look at that value and decide whether it's a whole number or not. Now, how can we do this? Well, there's a math operation that makes this possible, and it's called modulus. Let's go ahead and add a chop exec. All right, so we have our chop execute here. And we're going to leave this on value change. So this will run every time a value changes in this LFO. And yeah, like I said, we're going to use modulus to decide whether it's a whole number or not. Now, modulus takes a number, divides it by an integer, and then returns any remainder. So if you took, say your number was 4, and you were looking for the modulus of 5 for that value, then it would return 4, because it would be 0 5s with a remainder of 4. Say that your value was 7, and you're looking for the modulus of 5. What would it return? The answer, of course, would be 2, because you would have 1 5 and a remainder of 2. So it cuts out the whole divisors. After the division is made, it throws away the number of 5s, for example, and just returns the remainder. So what happens is if you set up a modulus correctly, then you will have a looping set of values, and when it goes to 0, you know you're at a whole number, because 5 with the modulus of 5 is 1 5 with a remainder of 0, right? And so we can use, in this case, we don't want to know about multiples of 5. We don't want to know about multiples of 2. We really just want to know multiples of single integers. So that would be modulus of 1. So every whole number, it looks to see if there's any remainder. And if there is, then we don't do anything. But when the remainder gets to 0, that's when we execute some stuff. All right, let me check my notes. Okay, great. So what we're going to do is we first are going to, down here on value change, we're going to add some code. So go ahead and make this viewer active. And let me zoom out. There we go. Make sure you put a tab in. And now I'm going to define a variable here. I'm just going to call it x for simplicity. And I'm going to say x equals put this in parentheses, op, open parenthesis again, dash, quote, LFO1, I believe, right? Is that what it's called? LFO1, yep. LFO1. And we want channel 0 from that. Channel, what's it called? Chan 1. Chan 1. Or you could put just a 0 there. That would work too. You could just put here 0. But that's a little, and that would work just as well. Whoops. If you put in the label, it makes it a little bit easier to understand what's going on. And that's a perfectly okay way to call that value. And then we need to finish this, so we're saying we're taking this value, and we're taking the modulus of 1. I don't even think we need those parentheses. I'm just going to leave them on, though, for now. Okay. Let's just go ahead and print that really quick. Print x. Now go ahead and dive out of the spinner. Open your text tab by saying Alt-T. This will bring up your text port. And now if we activate this button, you can see it creating these numbers. And these numbers are going to be going from 0 to 0.9 or so. See, it prints the same number over a couple times, but that's because it's doing it, it's rounding in a weird way. But you can see that this number goes from something low, something high, down to something low, and then starts counting up. So 0.1, 0.1, 0.4, 0.4, 0.6, 0.9, and then it rolls back over to 0.2. It's a little concerning that it's going that far, but all right, let's take a look. I should be seeing a little bit more values. All right, let's see. That was my stomach. All right. So what we need to do now is, if x is equal to 0, then we're going to stop the wheel. Okay, so the wheel right now is driven by a couple different methods. Let's take a look. The wheel here is driven by this LFO, I believe, right? LFO1, yes. Whoops, let's close this. Go away. Okay, LFO1. Now, this currently is driven by trigger 1. Where's trigger 1? There it is. So this is trigger 1. Trigger 1 creates the tail off, remember? It creates that ease in, this ease in and ease out that we're going to be using. And so far we have a sustain of 0. If I was to change this sustain to something above 0, you can see that it'll start rolling again at a slow level. If I zoom out here and take a look at the wheel, you can see it's slowly rolling. All right, so what we're going to do is we're going to, when we first trigger this, we're going to set the sustain level to something small, like 0.1 or something. And that way it'll spin fast, but when it slows down, it won't completely stop. It'll start rolling at this slower speed. And then when this modulus 1, sorry, I'm going back into spinner 1 here. All right. Here, this chop exec, when this modulus gets to 0, then it's going to stop. We're going to make that sustain go back to 0. Go away, text. I don't want to see you anymore. Okay? So, let's try this. All right, so instead of printing this, let's go ahead and comment that out. We're going to say x is equals, if x equals, or sorry, we need an if statement. If x equals 0, colon, new line, tab, then we're going to say op trigger 1 what do we need to do to adjust that? All right, so the sustain, we got to find out what this is called. You can hit the plus, and it's called sustained. Right. So we're going to say, so if x equals 0, then op trigger 1 dot par parameters, remember, sustain equals 0. Okay. Let's see, is that it? Yep. All right, great. Let's try this now. It should actually, every time it's running, it should stop as soon as it gets to whole numbers, but it's not. Why? Let's take a look. Let me uncomment this print. Now let's open my text export. Now let's just stop this for a second. I'm not entirely sure why, but you can see it's actually doing a lot better now than it was before. But you can see here that it never gets to exactly 0. It's going from 0.97 and then it goes to 0.06. So if we're testing for 0, it doesn't happen. It just doesn't happen. And that's because you're working with floating point values that are incrementing in different ways, and they don't ever get to a whole number. But it's not the end of the world. We can actually fix that and make it work just fine, even though it doesn't ever actually go to 0. Instead of using a equals equals, we can say less than. X is less than 0.1, I think. 0.01. Do I get that low? Let's see. No, that won't work. It's got to be, because I went from 9.7 to 0.06, so that wouldn't work either. So let's just say 0.1. Okay, let's try that. So now, if I go ahead and resume, it stopped because this got to 0.05, and 0.05 is less than 1, and so the sustain stops. Okay, so now you're like, oh cool, I want to try that again, and it won't work because we manually adjusted this sustain in the trigger. So what we need to do is create another either trigger, either chop exec or something else that will adjust the trigger chop sustain parameter to this low value when you push the button. Okay, so we could add something to this chop exec. We could add another chop exec, but we haven't looked at this yet. And this timer actually has this here, this pink arrow, and these are callbacks, which actually work kind of like the chop execs. So you can see they have the same sort of thing. Define, I mean, they're different names, but it's essentially can run script the same way. You have on initialize, on ready, on start, on timer pulse, while timer active, on segment enter, on segment exit, cycle start, cycle end, cycle, and done, right? We actually want to add some code to on start. We're going to say when this starts, we're going to adjust that sustain parameter. So tab in, and we need to say we have something called chop exec enable, or is that in my file? Oh, that's later. Okay. There it is. Op trigger 1. Okay, so here on start, op trigger 1 dot par. What's it called? We need to figure out what that sustain is. There it is. That's right. It's dot par dot sustain. Dot par dot sustain equals 0.1. Okay, that way it'll roll. As soon as you start, it won't roll that slow right away. It'll go ahead and do what it always did, but instead of stopping, it'll start rolling. And then when it gets to 0, then when the modulus gets to 0, it'll stop it. So let's try that out. So we just have this on spinner 1 right now. So there you go. You can see it stopped right at that 5. Let's try it again. See? Now it stops every time. Just this wheel stops every time with the number centered to where it needs to be. Let's dive back inside spinner 1. And you can see, actually, I don't have to. This should be. No, it didn't work. Because this should be a whole, something close to a whole number. Yeah, see, that didn't work. All right, so there's something going on. Okay, so I clipped out a major error on my part just to save y'all time. So yeah, we have this on start. We set the sustain level to 0.1. And then when the modulus of 1 gets to something close to 0, something less than 0.1, we set that sustain to 0, as you can see here, right? So that should work, but it doesn't. Let me show you that. So if this was working correctly, this LFO and this out should land on a number less than 1.1. And you can see that it probably won't unless we get incredibly lucky. It did that time. All right, let's try it one more time. See, it didn't that time. See, it's 5.3. So I was like, what is going on? And I figured it out. So what were we doing to make the wheel keep rolling after it was supposed to stop until it gets to thing, we were adjusting the trigger sustain level, right? Take a look at this value. When I hit the button, that should switch to 0.1. Then when the modulus gets to 0 and under this chop exec, then that should switch back to 0. But you can see that it almost instantly goes from 0.1 back to 0 before the number has stopped rolling. Let's do that again. See how it landed on a number it shouldn't have landed on. Boom. Why? Well, it is analyzing every single value here that's coming through this LFO. So if you happen to be something close to a whole number, then as soon as that 0.8 reaches 6, this shuts off. And we don't want it to do that. We don't want it to actually activate until the timer elapses. And then also this trigger adds a 2-second, as you can see here, decay. So we need to wait, disable this thing, or this chop exec here. We could either disable it, or easier is just turn off this value change script when it starts, and then when this timer hits done, wait 2 seconds, and then turn this back on. And then it will run its code when it's supposed to run its code, and it should stop it the way we want. So let's see if we can accomplish that. So here under timer callbacks, this is where we're adding stuff. All right, so when we on trigger start, we are doing that sustain thing, but we want to also, before we do that, we want to turn off that chop exec. So op, what was it called? Chop exec 2. Chop execute 2. Yeah, chop exec 2. Sorry, I keep forgetting what it's called. It's kind of late here. Dot par. It's going to be a parameter, and now we need to figure out what it's called. So here in the chop exec, while a value change, if I click on this, it's called, oh, surprise, surprise, it's called value change. So dot par dot value change equals, what do you think it is? You guessed it, 0. That will shut that off. Then when the timer is done, on done, we need to add some code. So first we need to take this code, the chop exec par value change 0, copy, paste it down here. Make sure you put in your tabs. There we go. And that's going to be 1. But we need this to be delayed. Now there's a couple ways you can, there's more than one way you can delay things in Python, but be careful. If you just Google search on how to do a Python delay, the easiest, naive way will actually pause the entire system for whatever number of milliseconds that you specify, and everything will stop, and then continue on after that wait, which wouldn't help us any. We want the things to keep rolling and so forth. So we need to do a special type of command called delay, a run command, and a run command with a delay frames attribute. And this is a Python method that works in Touch Designer, and it's very handy. So the way it works, you have to create a, at least it's easiest, to create a what am I calling it? A variable that contains this reference right here. So we're going to call this variable. We're going to call this delay underscore script equals, and then put this in quotes. All right, so we've defined this as delay script. Now we can run delay script and put a comma and then put in delay frames and make sure you put it that way. There it is. Okay, great. Yeah, so make sure you capitalize the F in frames. This is a variable that run understands, and you're going to put a number of frames that we want to delay it, which would be 120 to get that extra 2 seconds that the extra 2 seconds that the trigger adds, right? Because it has this 2-second delay decay length. And so then this will that chop exec will be turned off when you start, and then when it ends after 2 seconds or 120 frames, it'll be turned on, and then it will start doing what it's supposed to do. So let's try that out. And uh-oh, what happened? That value changed. It looked like I had an error there for a second. Let's take a peek. Oh boy. There we go. What's happening? Op exec par value change equals 1 line 1 name error. Chop exec 2 is not defined. Sounds like a typo. Let's take a look. Chop exec 2. Oh, do boop. Boop. There we go. That's what we messed up. Let's see, is it up here too? Oh no. Boop. Boop. There we go. That should fix it. Let's try it again. Now you can see the sustain level is set to 0.1. Then it got changed to 0 here at the end. And look where we landed. 6.05. That's pretty damn close to 6. So let's try that again. Yep, 8.05. That is really close to 8. All right, so that's working. And so now we just need to conform those changes to here. Let's just copy and paste these other spinners, right? I just want to make sure there's nothing in here that I need to copy. I haven't done that yet, right? No, okay, great. Yeah, so let's just copy spinner 1, get rid of spinner 2 and 3, copy and paste it, spinner 2 and spinner 3. All right. They're rolling for some reason, but I think if we hit the button, it should reset things. Boom. And check it out. 6.06, 4.06, 7.09. Those are all less than 0.1. And if we look at our slot machine, they're lined up perfectly. Let's hit the handle. All right. Except for they all look like they're all lining up. They're all stopping at exactly the same time. And I know why. And you know why? Because of the seeds. because of the seeds in the random. So we have to go back in here and change something. I believe it's here. Yep. Random speed equals par the frame. So we need to make sure it has a different seed. So we're going to change that to +2, and we're going to say this random, and we're going to add a value to this. We'll say +3, and we'll do 4 and 5 on the other one. So then go out of that spinner 2 in here, spinner 3 now. Remember, if you ever get lost about where I am, take a look at the address up here. It tells you where I am. Okay, so here in Chop Exec, I want to say plus. Let's say what do we have? 2 and 3. Let's do +4 and +5. That way we get different seeds for every action in each spinner, and we shouldn't have identical random numbers, which is kind of defeats the purpose of random, right? So let's try it again. Boom. Looking good. You can see how they slow down and they land right where they're supposed to. And our wheels are going different speeds, you can tell. And they don't all stop at the same time. Okay, so looks like the last couple times we've had them stop in the order we want them to stop, but that has been random. See, this time it didn't. So that's the next thing we need to work on. Okay, so we just need to adjust the code in spinner 2 and 3 to make a consistent order of wheel stoppage. And basically, we're going to add, let's take a look at that. So in spinner 2, where we calculate the time here, we have timer 1 par length equals this random amount times 5 plus 3. That gives you a range of from 0.3 to from 3 seconds to 8 seconds, some kind of random amount in between there. But what we really want to do is also add the amount of time that the previous stage waited. So that way this is always longer than that. So let's see if we can do that. Let's see. Do I have that code in my notes? Looks like I do. Okay, great. So par length equals to plus times 3. Okay. So what we're going to do is, instead of making it go from 3 to 8, we're just going to have a random time that adds between 0 and 3 seconds. And actually, let's make it it'll add between 1 and 3 seconds. So let's say times 3. Whoops. Plus 1. Okay, so that will actually, let's say times 2 plus 1. So that way it'll be at least 1, and then it will be up to 3 seconds longer than the previous. And now we have to add the previous. So we say plus, and then this is where we have to point to something that's in a totally different container. And so we're going to use an absolute path instead of our relative path that we've been using in the past. So we're gonna point to the length of the timer 1 that's sitting in spinner 1. So actually, let's do it this way. Let's use a variable, and let's call it stage 1. So you're going to have this random amount times 2 plus 1 plus the whatever the amount in stage 1. Now we need to define stage 1. We can do it here above these definitions. We can say, let's see, we're going to say stage 1 equals op. And this is where it gets hard because we have, like I said, we have to use an absolute reference to point to that other timer parameter. So we're going to say open quote, single quote, / project 1. See this here? This is project 1 spinner 2. We're going to say project 1 / spinner 1 / and then the operator, which is called timer 1. Okay, single quote, close parentheses, and then dot par, dot length, Yeah. So that should now add this, the amount that's sitting in this length, and I can show you where that is. If I go out of spinner 2, come on, there we go, and I go into spinner 1, we're talking about, on this timer, this length here. So it's going to add 5 seconds and then some random amount between 1 and 3 seconds after that. Okay, so let's try that out. Actually, let's just go ahead and add the change to spinner 3. So let's go back. I'm back in spinner 2 now, right? See, I'm in spinner 2. And I don't want to add an object. I'm going to grab this code so I don't have to do it again. Here, I'll just do all of this. So grab all of this code, copy, and now go out and go into spinner 3. This is in the chop exec. There it is. Let's just paste it up here, and I'll just clip out what we don't need, right? So we need that. Oh, I see. Let's just clip this out. Boom. Okay, so now that's back to the way it should be, except for we just need to conform this. Instead of saying timer spinner 1, we want to point to the amount of time that we waited in spinner 2. And so now op timer 1 par length equals some random amount of time between 1 and 3 seconds plus stage, let's call this 2. Stage 2. Make sure you change up here to stage 2, and then down here you change that to stage 2. All right, that should do it. Let's give it a shot. So hitting the button, they roll, rolling like thunder. Stops at, but why? Let's take a look. I feel like it's not quite working right. That's right, 1. No, that's wrong. All right, so something's up with that wheel 3. Okay, the homework is here on the website. You are supposed to patch along with this online lesson that you just watched. I assume you have been doing that. And then in addition, I would like you to these 2 YouTube videos patch along with the Matthew Reagan tutorials on logic and Python. And then email me your patches and put them on your blogs for next week. Okay, great. So he's going to go over the basics of logic operators, and then we'll look at some more advanced forms of logic operators next week to create more interesting payouts than just all the same. All right, have a wonderful week. Aloha.